From the credit score you get, to the news that pops up on your feed, even to the job application you just sent out, AI is quietly making huge decisions that shape our lives. But what happens when these super powerful systems get it wrong? I mean, when an algorithm discriminates, who or what is actually responsible?
And this isn't some science fiction movie scenario. We're going to kick things off with a real-world story, a glitch that exposed a massive, massive legal headache right at the heart of modern AI. So, picture this. It's 2019, the new Apple Card comes out, and it's powered by this really sophisticated algorithm. But then, people start noticing something weird. It's offering wildly different credit limits to husbands and wives, even when they share everything, bank accounts, assets, the whole deal. One tech entrepreneur tweeted that he was offered 20 times the credit limit of his wife. And then, get this, even Apple's own co-founder, Steve Wozniak, said he got 10 times the limit of his wife. The outcry was, as you can imagine, immediate, and New York State launched a full-blown investigation.
Now, the Apple Card issue wasn't just a PR nightmare. No, it blew the lid off a critical legal question that we are all wrestling with today. This quote here really nails it. When an AI system harms someone, it creates this fog of uncertainty. Who exactly are you supposed to sue? And that is the central dilemma, isn't it? Who's to blame? Is it the company that decided to use the AI? Is it the developers who built it? Maybe the data scientists who trained it? Or is the algorithm itself somehow at fault? This is the accountability puzzle we're going to try and solve today.
To even begin to find the answer, we first have to understand what makes this new generation of AI so fundamentally different from older technology.
Okay, so this is the key distinction right here. Old algorithms were static tools. Think of a simple calculator. You program a fixed set of rules, and 2 plus 2 will always equal 4. It's predictable. But machine learning, that's a whole different beast. It's dynamic. It's not programmed with rules. It's trained on data. And that allows it to adapt, to evolve, and to find patterns all by itself. A really common way this is done is through something called supervised learning. And honestly, it's kind of like teaching a toddler with flashcards. You show the AI thousands and thousands of pictures labeled cat and thousands labeled dog. And over time, it starts to learn the underlying patterns, the features that make a cat versus a dog, so that it can accurately identify them in new pictures it's never seen before. It learns to generalize from the examples it's given.
And here's the thing. This new learning ability isn't just for recognizing pets or setting credit limits. It's being used to make life-altering decisions all across our society, right now.
For instance, in courtrooms across the United States, AI systems are being used to help judges make huge decisions about bail and sentencing. They do this by trying to predict the risk of a defendant committing another crime.
One of the most well-known of these systems is called Compass. An investigation found that it was systematically assigning higher risk scores to African Americans. Now, the designers argued, hey, the system can't be biased because it never even looks at ethnicity data. But here's the catch. The AI was so good at finding patterns that it could effectively figure out a person's ethnicity from other data points, like their zip code or who their friends are. And this is very likely the exact same thing that caused the Apple Card mess. The algorithm found these hidden patterns in the data that just happened to correlate with gender, even if gender itself wasn't a direct input.
This technology is also being deployed at our borders. There's a pilot program in Europe, for example, that's using an AI-powered lie detector to screen migrants trying to enter the country. This system is called Border Control. Uses an AI avatar to interview travelers. It analyzes their micro-expressions, these tiny involuntary facial movements, to see if they're being deceptive. If the AI gets suspicious, it flags that person for a much more intense screening by a human agent. I mean, think about that. It's making a high-stakes judgment call based on the twitch of an eye. So these examples, from credit to crime to border control, they all bring us right back to our central question. When these incredibly complex, self-learning systems make a mistake, who is legally on the hook? And it really is a liability maze. It is so complex. I mean, you have all these different actors involved. Was that the data scientist who maybe chose a biased set of training data? Was it the vendor who sold the system without the proper warnings? Or was it the bank or the government agency that used it without enough oversight? For the person who's actually been harmed by the decision, trying to navigate this is, well, it's nearly impossible. But the challenge is even deeper than that. It's what experts call the black box problem. With the most complex AI models, not even their creators can fully explain how the AI got to a specific decision. So with the Apple Card, the engineers might not be able to point to the exact piece of data that caused the gender gap.
The Y is just locked inside this complex web of calculations that is basically beyond direct human understanding. So, if we can't always trace the decision back to a single person, and sometimes we can't even understand the logic, how are lawmakers supposed to create rules for this new world? Where do you even start?
Well, one of the leading global efforts is the European Union's AI Act, and it takes a risk-based approach, which is pretty clever. As this chart shows, it basically sorts AI into tiers. Anything that's considered an unacceptable risk, like a government social scoring system, is just banned outright, gone. Then you've got high-risk applications, like AI used in law or in hiring, and those face really strict rules about transparency and making sure human is in the loop. And finally, for low-risk systems, there are few, if any, requirements.
And this brings us right to the core challenge of our time. We're trying to build a legal framework for a technology that is constantly learning and evolving, often beyond our direct control. So how do you write the rules for a technology that is, in a way, learning to write its own rules? Answering that, well, that's the defining legal and ethical test of our generation.